Hello, this is Cheyenne from Visual Components. In this video, we are going to be working with some tools in the geometry section. Before we get started, make sure that you are using Visual Components Professional or Premium because you need to have access to the Modeling tab here. To find the tools, you go to the Modeling tab, you go to the Geometry section. Within the tools, you can find some feature tools here. In this video, we are going to be working with these feature tools only. Now, I'm using a CAD model which was designed in SolidWorks, and then I have imported that into Visual Components. Now let's go ahead and use some of the tools that we have here, and let's start with Select Identical. Now, if I keep the selection level at feature level, I should be able to pick this or the tray geometry feature. If I go back to the Select Identical, and if I keep it at geometry set, you should be able to pick this and this one separately. So let's put it back to feature level. I select this geometry feature, I zoom out a little bit, and now if I click on the find, it's going to find all the identical geometry features for me in the component. Now that we have all these four identical features selected, we can use another tool, merge for instance, to merge them and create one geometry feature for all of them. So now when we merge them, you realize that all those four geometry features are now one geometry features, and we are left with these empty transform features. You can go ahead and maybe right click and remove empty, so it removes all the empty transform features for you. But the point is, we have now merged all those four geometry features. So when they are merged, you should be able to move them together. We can still maybe split them back into separate geometry features using the tool split. Now if I go ahead and set the split level to maybe set, I can, let's zoom in a little bit here. I can select this, and I can select that red part as well within the set level. If I put it to face, for instance, I should be able to select one face only and maybe split that into separate geometry feature. Let's go ahead and do that. Now I have this face as a separate geometry feature, and I've got the rest of the screw as another. We can use split and set it to faces, so it's going to select all the faces that are kind of connected to the one that we select. We already split this face into a separate geometry feature, and that's why it's going to only select this face. But if I select this face, it's going to select this face, also other faces that are kind of attached to each other. So that's about split level, and using the split tool, we used split, select identical, and we also used merge. Let's go ahead and use maybe a remove holes. So if you see, there are holes on the tray, 4 of them on this side. If I want to, I should be able to remove these holes using this remove hole tool, and I keep the selection level at feature level. I expand this so you can read the definitions here. So I keep it at the feature level. I only want to remove the circular holes, so I check this and I keep the default values for this parameter. I select the geometry feature of the tray and I click on the apply. You see that the holes are not removed from underneath. You can still see the circle here. It looks like that the hole is capped from the bottom and it's still open from the top. So you might say the tool is not working, so one workaround for that is use another tool which is called slice. So with the slice, if we slice this tray, one portion of that, and then apply the remove holes again, I think we should be able to remove the holes. Using slice, I choose a snap type to face, so I want to select a face. I select this face, and the preview shows the slice is going to happen here, which is based on this plane offset. If I change this plane offset value to 100, it goes a bit further into the component. If I set it back to 50, it's going to end up here. If you don't have this flip offset checked, the preview shows that the slice is going to happen outside of the component, which we don't want that. So we check the flip offset, we slice it. Now we have this section as a separate geometry feature, and we've got the rest of the tray as another. So we can, for instance, move the rest of the tray individually. Now we go ahead and select the geometry feature that we sliced. We go to the tools and we choose again remove holes. We keep the default setting from the previous step, and we click on the apply, and you see magically the holes got removed. You don't see any holes on this geometry feature at all anymore. Now let's go ahead and use the other tools here. Let's go ahead and use maybe collapse. So before using collapse, I would like to show you an example. Now you know that these are geometry features. These here are all geometry features, and we were able to use tools such as split for them. We could split faces. If we had, for instance, a primitive geometry, which is only a block feature, we shouldn't be able to use the tool split, for instance. If we keep it at the face level and we select this face and we try to split that, you see right away in the output panel it says some of the selected features need to be collapsed first. It means for using tools such as split, the feature must be contained in geometry feature first. But this feature is only primitive, it's just a feature, it's not a geometry feature. So I go to the tools and I collapse this feature. Now it's a geometry feature. I should be able to use split and select this face and split that into a separate geometry. You see that this face is now a separate geometry feature. So that's what the collapse does. It collapses a feature into a geometry feature. And I think it should be the same case for using merge. Let's go ahead and clear the layout. And let's create a new component. And create a block. Create a cylinder, for instance. And let's go ahead and select both of these features. And we try to merge them. You see nothing happens because they are not geometry features. I have both selected. I can move them, together. However, they are still not merged together. So the way I can merge these two together is first collapse them first into geometry features, and now I should be able to merge them together and only have one geometry feature. There are two other use cases of the collapse tool. Let's go ahead and create a new component. Let's go ahead and create a box feature and maybe creating a cylinder feature as well. So if we move the cylinder out of the way, you see that we've got two different features in one component. Let's go ahead and create a transform feature. Select the block, holding down Control, selecting the cylinder, dragging them and dropping them under the transform feature, and maybe create another branch. So now we've got this hierarchy with a parent transform feature on top, and we've got the rest of the hierarchy. We can use the collapse tool to collapse this section, the whole hierarchy underneath this transform feature 1, into a geometry feature. So we collapse the features, it collapses all the features in that particular hierarchy into one geometry feature. Now we've got everything as one geometry feature, so that's kind of good to understand about the collapse tool. The other thing about the collapse is, let's go ahead and create maybe a cylinder, and let's move this cylinder out of the way. Let's create a sphere. So you see, still the component's origin is at the world dead center. It's 0, 0, 0. But the origin of this cylinder, this feature, is somewhere else. It has an offset with respect to the origin of the component itself. Now, if I go ahead and collapse this feature, tools, and I collapse this, you see that the position matrix of this feature is now reset back to the component's origin. In the 3D world, you don't see the location being changed, but in the background, the offset of this feature is now reset back to 0. So the feature keeps its offset while retaining its location in the 3D world. So when you collapse a feature that has an offset from the origin of the component itself, the collapse resets its position matrix and keeps the offset of the feature. And it doesn't really matter in what order you do that. What I mean is, let's go ahead and delete these, and let's go ahead and create a cylinder again. If I collapse this cylinder without applying any offset, you see still the origin of the feature is exactly on top of the origin of the component, which is in the world center 0, 0, 0. Now if I apply the offset to the geometry feature, and let's go ahead and create a sphere to see the world position. So the origin of this geometry feature is here, and still the origin of the component is here. So now if I go ahead and collapse this geometry feature again, you see that its position matrix is now reset. So it kind of saved the offset. It did not change its position in the 3D world, but its position matrix is now reset. So now the origin of this feature, geometry feature, is on top of the origin of the component itself. And let's go ahead and use maybe merge faces and invert. Like go ahead and drag and drop the tray that we worked before. It is the same tray. Let's go ahead and use merge faces. Before we use merge faces, let's slice this tray geometry feature once again. I try to use this face. The preview looks good. Now if I merge this sliced geometry feature with the one here, we merge them back together. See, they're not merged, so we go ahead and do that once again. I merged them, now they are merged into one geometry feature. But you see, even though they are merged, but you can see this line here, which is a representative of a hard edge. So we can get rid of this hard edge with using merge faces. So what merge faces does is that it takes a tolerance, which says how far apart the vertices on the faces should be in order to put them on top of each other and merge the faces. So I set the tolerance to 0.5, I select this face, I hold down Control, I select this face, and let's see if the tool works. I used merge, nothing happened, and for some reason it splitted the geometry feature back into two separate geometry features. Now I select one geometry feature, holding down Control, selecting the other one. I go to the tools and I merge them back together. Then I use merge faces again. I select this face, holding down Control, selecting the other face, and I try to merge them. Now you see magically the hard edge disappeared when I merged the faces. So that's the way merge faces work. Let's go ahead and use the last tool here. We have Invert. So what Invert does, it inverts the geometry feature, for instance, that we are going to choose. You can also set it to set or faces or face. It inverts whatever level that you're choosing in such a way that you can see the component or the object inside. Let's go ahead and see what it does. So if I select this feature and if I click on Invert, now you see nothing has happened. So that's because we have the backface mode on. If you double click on the geometry feature, it selects the component, and if you turn the backface mode off, you see that when we inverted the geometry feature, now we are able to see inside of that feature. So what it did, it inverted that particular feature which was facing the 3D world camera. So it's not rendering that feature, and we are able to see inside of it. You can do maybe the same thing at different levels. Let's go ahead and select the feature we just inverted, and let's go to the tools and select the invert again, and we invert this again, so it's back now, it's into original condition. Let's go and invert it, but set the invert level to maybe face. Now I only want to select this face and invert this face. So it doesn't render that face, and now I'm able to see inside of this geometry feature through the face that just got inverted. For instance, let's say you have a factory and you would like to see the factory from inside and not rendering the outside walls. If you turn the backface mode off after you invert it, you should be able to see inside of the factory, and in this particular example you are now able to see inside of this geometry feature through the face we just inverted. Now let's have another look at the invert tool, but from a different perspective. I have imported the same tray. I have set the rendering mode to realistic shaded, and if you notice, some parts of the tray are much darker than the other parts, like these edges here are much darker than the inside of the tray. So something is telling that this geometry has a problem. It's not a rendering mode problem. If you select the component and if you go to the backface mode and we turn it off, we can see that the geometry of this tray has been flipped upon importing. It still renders every face, but only shows one side of it. The reason why we keep the backface mode on, despite slowing down the simulation, is that we want to make sure that whatever geometry we have imported is not flipped. So we can use the tool Invert. So let's go ahead and select the features on this tray component. We go ahead to the tools and we use Invert. We keep it at the feature level, and we try to invert it, you see that it looks much better than before. Now those dark parts are gone and the rendering shows that the geometry is in a better condition than it was upon importing. So even if we turn the backface mode off, you can see still the result is much better than the time when the geometries were flipped and we didn't invert them. So let's go ahead and turn the backface mode on. You can see that those dark parts are all gone, which means that all the inverted, all the flipped geometries are now inverted. So we can render both sides of the faces. So with this tool you can invert the geometries that have been flipped upon importing. I have imported another model, a robot model here. You can see that in this model we get some dark parts on the upper parts and we get lighter parts on the lower sections, which is kind of weird. It should be almost vice versa. We should get darker color in the bottom parts and we should get brighter colors on the upper parts. So we select the robot, we select the component, and we turn the backface mode off. You see that the same thing happened with the geometry of this robot. When we turn the backface mode off, we can see that still every face is being rendered, but it's only showing one side of it, meaning that we are able to see through the geometry of this robot. You can see that I can see through the geometry features here. So the way to fix it is, let's go ahead and select all the features. Let's go to the tools. Let's use the invert, keeping it at the feature level, and you see that the result is much better. We get brighter colors on the top side, we get a bit darker colors on the bottom side, and if we even turn the backface mode on, you see that not much difference is visible. So all those geometry features that were flipped upon importing are now being inverted. So in the rendering mode, both sides of the faces are being rendered. So that's about the tools that we had in the feature tools. We use split, we use invert, merge faces, collapse, we use slice, select identical, and we use remove holes. Let's go ahead and see, for instance, if we can set the length of the tray. As you see when you import it, let's clear out the 3D world and let's import the tray once again. For instance, one of the use cases of maybe the tool slice could be, for instance, when we want to set the length of this tray. When you import a CAD file, you have no property. If you want to change the length, the width, or the height, you need to go ahead and create a property. We just create one, we call it capital L, and we want to set the value or the length of the tray to 300. Let's now do a quick measurement. It is now 400 millimeter, so we want to set it to 300 millimeter using the property we just created. We right click on the parent transform feature, we create another transform feature on top of it, and we use scale along X. We had desired length, what we measured before was 400, so it applies the scaling. Now the length of the tray is 300 millimeter indeed. However, you see when you scale it, the holes here are no longer circle, they are oval. So scaling ended up distorting the geometry. So the proper way of making this CAD file parametric is first getting rid of this expression. Then we select the tray geometry feature, go to the tools and we slice it. We try to select face, so we select this face, we keep the settings as before, we slice it, and then we do the same thing on the other side. We select the geometry feature, tools, slice, we select this face and we slice it. Now we've got this mid portion a separate geometry feature as these two, which means if I want to change the length of the tray, I should be able to change the scale of this midsection without affecting the geometries on either side. So I select the midsection, I create a transform feature, now I try to scale it. So it was capital L minus 100. 100 is from the slicing. We sliced 50 mm from either side, so in total 100 mm, and we are left with 300 mm. Now this mid portion should be 200 mm in length, which is now 200 mm. The only thing we need to do to form the tray is to move these and kind of attach them to this midsection. So we select one and we create a transform feature. We go ahead and use translation along X. So I have worked out the math before, so it's minus capital L multiplied by 0.5 plus 200, and it should now be working fine. I select the other one, I do the same thing, I group it, so it creates a transform feature for that. Translate along X, capital L multiplied by 0.5 minus 200, the same expression but with a different sign. And it does that. So let's now go ahead and move these screws to the holes. I select one, I hold down control selecting the other one. I can merge them. So now I have one geometry feature, I create a transform feature, I use the same expression for translation, 0.5 plus 200, and I do the same thing for the other side, selecting one, holding down control, selecting the other one, and I can here even right click and merge faces, right click, create transform feature, translate along X, capital L multiplied by 0.5 minus 200, and now seems to be good. Now we need to make sure that after we slice the tray, it is still intact when we change the length. So if we change to 400, it looks good, 500, it looks good, and you see still the holes are circle, because we're not scaling this section at all, we sliced them off. And now I've set the length to 500. Let's do a quick measurement to see if it's 500, which is indeed 500. So that was about the tools that we had, and that was about like one use case example. Hope you enjoyed the video. If you have more questions, please visit our forum, or you can even check the help documentation on these tools to understand how they worked. Thank you very much. Stay tuned for more videos.